Hey guys, welcome to EduKaji. If you're first time here, allow me to introduce myself. My name is Walter and I'm a scientist as well as a chemistry tutor for the past 8 years. Right, if you guys have any question I want to ask, just ask me through the chat and I'll be able to answer you. Right, let's dive right in. So let's take a look at section A. Let me just show you one more time. So this is the Johor State Trial Paper for 2021, which is 2 years ago. And if you were to see over here, hold on, sorry, okay, again. So this is Chemistry, Paper 2, 2021 for the Johor State Trial Paper, 2021. Let's go to section A. For number 1, the diagram number 1 shows the periodic table of elements. Then they ask you, the letter used are not the actual atomic symbols for the elements. So they give you P, Q, R, S, T, U. Based on diagram 1, what is the meaning of period? So they also ask you to define what period is based on this. It is actually the horizontal row of the periodic table. Okay, so you can put here the horizontal row in the periodic table. So you can just use that as 1 mark. Usually we'll say of the periodic table. So you can just add on a little bit for the description of elements. You got 1 mark. All right, then I ask you a second question for B here. What is the basic principle used in arranging the elements in the periodic table of elements? So that is the increasing proton number. So it's a very simple one, right? Increasing proton number. Okay, then you get 1 mark as well. And then we have element T is argon, name group of T. So group T can be normally given the name of noble gas. All right, noble gases, or sometimes we call them as inert gases. That represents the last group of the periodic table. Okay. Next one, D, which elements have the same chemical properties? Give your answer for the reason. So normally what happens here is that normally if you are placed in the same group, you have the same chemical properties. Okay, the reason why is because they have the same number of valence electrons. So then they can actually react similarly. So you see over here, P and S is the answer. So if you answer P and S, you get 1 mark already. And then you explain why. Because both elements have the same number of valence electron. Okay, so there's only 1 valence electron inside because they're group 1 elements. All right, let's go to number 2. Diagram 2 shows the graph of the temperature against time for cooling of acetamide, which is C2H5NO in the experiment. They give you points plotted in and B, P, Q, R, and S, which represents different stages of the cooling curve. So what is the meaning of freezing point? So the freezing point is the temperature where the liquid changes to solid at a certain pressure. So you see here, very simple, you just put here the temperature in which a substance changes from liquid to solid. Okay. And then for B, state the freezing point of the acetamide in this experiment. So we will say that it is this point, this flat point between QR is where you can find the freezing point of acetamide. So you can see that this is actually 80 degrees Celsius. So for this one here, you just put 80 degrees Celsius. Now you have to include the unit or else it will not be able to give you marks. So you must put that 80 degrees Celsius. Without the degrees Celsius, you won't be able to get marks. Then for C, state the type of particle for acetamide. So acetamide is actually a type of covalent compound. So a very simple covalent compound means they're actually molecules. So the type of particles over here will be molecule. One mark over there. Next, explain why there is no change in temperature from point Q to point R. So we see over here, between point Q and point R, the temperature remains constant for a short period of time. The reason why is because the particles are actually absorbing the heat energy to try to overcome the force of attraction. So you put here 2 marks here to explain that. The heat energy is absorbed by the molecules to overcome the forces of attraction between the molecules. I should be able to get 2 marks in total. So the first mark comes from explaining that the heat energy is absorbed. All right, yes. And then the next part is to actually explain why they absorb the heat to try to overcome the force of attraction. So having these 2 key terms over here, you'll be able to get a total of 2 marks already. Right, number 3. Diagram 3 shows the information of the mole represented by the symbol of Na. So what is represented by the symbol above? So for this Na symbol, it actually signifies Avogadro's constant. So you can put here Avogadro constant. And I ask you to state the relationship between the number of moles and number of particles. So you can just say that the number of mole is equivalent to number of particles divided by the Avogadro's constant. So what you can do here is very simple. You can say here number of mole. You can write it in the form of words if you want to, or you can write out the formula straight away also can. So you say here number of mole is the number of particles divided by Avogadro constant. Or if not, you can do this also. right, divided by Avogadro's constant. So either way, you should get should be able to get 1 mark in total lah. Right, next. See, diagram 3.1 shows the structural formula of a gas at room temperature, which is colorless, highly irritating gas with a pungent and suffocating odor. So this is actually referring to ammonia lah. Okay. Now, what is the molar gas? What's the volume of 0.01 mole of gas at room temperature in cm cube? So first thing to remember, it is 0.01 mole of gas at RTP, and you have to give the answer in cm cube because you actually asked for it. So whenever they ask for a certain unit, you must follow. Otherwise, you can just write dm cube or cm cube, it doesn't matter lah. So over here, we have 0.01 mole of gas at room temperature and pressure. So the volume of gas is very simple. So volume of gas will be equivalent to number of mole multiplied by molar volume. So that would be 0.01 mole multiplied by 24 dm cube. Then you should be able to get 0.024. 0.24 decimeter cube. And if you want to get it in what's it called? If you want to get it in cm cube from dm cube, it will be multiplied by 1000. So 0.24 divided by 1000 multiplied by 1000 will be 240 cm cube. So that's your final answer in cm cube. All right, how many molecules are there in the gas above? So we have the number of moles over there. So number of molecules, or should I say number of particles, is equivalent to number of mole multiplied by Avogadro constant. So it's 0.01 mole multiplied by 6.02 times 10 in the power 23. If you calculate it using a calculator, you'll be able to get 6.02 times 10 in the power 21 molecules. All right, so you get 1 mark over here. Next, pentane, CH5H12 burns completely oxygen to produce carbon dioxide and water. Write and balance chemical equation for this reaction. So very simple. Whenever you burn a hydrocarbon, you will end up having carbon dioxide and water. So you have to press, you have to add O2. And then about 5 carbon atoms means 5 more carbon dioxide. And 12 hydrogen atoms will be 6 H2O. And after that, just balance off the number of oxygen, which is 8. Once everything is balanced, you get 2 marks. Right, next we go to question number 4. Diagram 4 shows the monomers of pterylene, which is a type of synthetic fiber. Left side we have a double alcohol. On the right side we have dicarboxylic acid. So what type of polymerization for pterylene? The answer is at condensation polymerization. Okay, next, draw the structural formula of the polymer that is formed by these 2 monomers. So I would say here very simple. You're supposed to technically draw the the polymer itself. So what you're going to do is that you're going to combine this structure and this structure together. So normally for the alcohol part, we remove the H on both sides. for the carboxylic acid part, we remove the OH on the other side. Then you'll be able to form water molecules later on. Then after that, this O over here can combine with the C over here. And after that, you should be able to get your structure already. So it looks something like this. Connected to the carbon on the other side. And then you're supposed to draw the hexagon ring. All right, again with the double bond to the O, and then just branch out on the other side. Just cover up the whole structure, and remember to indicate the double bonds over here. So the structures follow exactly as what is given to you in the diagram. Then it should be correct already. So this is the structure of pterylene, right? One of the section of pterylene. So once you're done with it, at the end, to represent a large number, and then you should be able to get 2 marks already. Okay, now explain why polymer formed in B1 also named as a polyester. So it's very simple because, right, whatever that's formed over here is actually an ester linkage. So if you have many of these ester linkage, we call this as a polyester. So that's the simplest answer you can give, because the structure contains ester linkage. Right, pterylene is widely used in the textile industry. However, water pollution has occurred due to wastewater disposal. Explain the impact on the environment if wastewater is not well managed. So this is more of like a K-bar question. All right. So explain the impact on the environmental wastewater if it is not well managed. So you can put here, most of the time wastewater definitely means like, factory effluents or different types of chemicals spilling. So most of the time, right, the easiest answer to give is actually the death of aquatic organisms. I mean, there's a lot of other answers you can give, all right? For example, you can say here, it may be able to release of harmful and toxic chemicals, right? Water supply become disrupted. A lot of things you can write inside there. However, I think the easiest one to write over here is actually the death of aquatic lives. So you put here aquatic lives will be destroyed. Just like the Sungai Kim Kim case where we saw last time, it actually caused the whole river to be black in color, and then it actually killed off most of the life form inside, fishes, plants, and so on. Not even microorganisms can survive. And the use of dyes in butter industry has caused the river pollution. How do we solve the problem? By using green technology. So when they say use green technology, right, you have to apply what you have learned before inside that particular subtopic. Okay, so we'll say that this dyes, right, which is the coloring material, can be separated using electrocoagulation process. That's the easiest one, okay? So you can say here, the dyes, okay, the dyes can be separated from the water using electrocoagulation process. Okay, although once it's coagulated, you can just filter them off, then can really, okay. If you want an alternative answer to that, you can also give such as, you can say what happens after that lah. So you can see here, once the dyes are coagulated, the dyes will separate. All right, the dyes will separate and can be removed as a sludge. Then it's done already lah. Okay, so these are the process in order for you to sort of like separate off the dyes and whatnot. Okay, next. Then number 5. Diagram 5 shows the apparatus setup used to determine the heat reaction between sodium hydrogen carbonate, NaHCO3, and hydrochloric acid. So right now you can see here is that after adding in sodium hydrogen carbonate, the temperature from 29 degrees Celsius became 18 degrees Celsius, right? From 29 degrees Celsius to 18 degrees Celsius. And it is added to 20 cm cube, 2.0 mole per dm cube of hydrochloric acid. So what happens here is that the temperature has decreased, okay, from 29 to 18 means this is actually an endothermic reaction. So after that, what happens is that it says here the initial, let's see, to 20 cm cube of 2.0 mole per dm cube of hydrochloric acid is poured into a plastic cup. Initial temperature of the acid is recorded. Then 1 spatula of sodium hydrogen carbonate is added, and then mixture is stirred, and the final temperature is recorded. All right, this is the equation that they give you. So for A, state one reason why plastic cup is used. So plastic cup is also a heat insulator, so you'll be able to reduce the heat loss to the surrounding as well. So you put it over here to reduce or to minimize heat loss to the surrounding. All right, and then state the type of reaction occurred based on the change in temperature. So we can say that the type of change here will be very simple. You can say that it is endothermic reaction because it has proven to you that the temperature is decreased after the addition of the salt. So therefore, it is an endothermic reaction. All right. Next, okay, for C, based on the information and the results of the experiment, calculate the heat change, Q, for the reaction, okay? Now, this is no need to write delta H. Delta H is at the bottom over here. So we're going to do the Q first. So Q is equivalent to MC theta. Now, M is referring to the mass of the liquid. Now, we do not need to include in the salt because before that, the salt was not added into the water. The solution. So when you add in the salt, then it will slowly dissolve, right? But it doesn't matter. What matters is that the heat is now dissipated inside the hydrochloric acid. So we follow the volume of HCl. So it is only 20 cm cube. So 20 cm cube means 20 grams. Okay. So 20 grams multiplied by the constant over here, which is 4.2 joules per gram per degree Celsius, multiplied by the change in temperature. So just now you saw, right, it was from 29 degrees Celsius, it became 18 degrees Celsius. So there's a huge change over there. And the change here will be, let me see, 29 to 18 means 3 degrees Celsius, isn't it? 3 degrees. No, sorry, it's not 3 degrees. It is supposed to be 9 plus 2, 11 degrees Celsius in total. So then, of course, multiply by 11 degrees Celsius, and let's see how much that is. So if they calculate everything correctly, it will be 924 joules of energy. Then converting that to kilojoules, divide by 1,000. So you got 0.924 kilojoules of energy. Get all this correct, you can get 1 mark. Then using the information, we'll calculate heat of the reaction, delta H in this reaction. So the delta H will be Q divided by N. So the first step over here is to calculate what N is. So N is a number of mole. We follow the solution. So we use MV over 1,000. Okay. So in this case, like we saw, right, it is actually 2.0 mole per dm cube multiplied by 20 cm cube for the acid. And after that, divide by 1,000. And the number of mole over here is actually 0.04 mole. All right. And then now that we can have the N ready and we got the Q. So we can now calculate delta H straight away. So delta H will be 0.924 kilojoules divided by 0.04 mole. And if you get everything correctly calculated, you'll be 23.1 kilojoule per mole. Now, since it's an endothermic reaction, you have to put a plus sign in front, okay? Regardless of whether it is an exothermic reaction or an endothermic reaction, you must put the symbol in front of your delta H value. So if it's a negative value, it's for the exothermic reaction. If it's the positive value, then it must be for the endothermic reaction. So either way, also you must put a plus or a minus sign in front. Just because it's a positive value doesn't mean you don't have to put it inside. Remember that in exam, in your SPM, just in case, if this type of question would come up and it becomes a endothermic reaction, for example, you have to make sure that this is actually used. Okay, plus sign, then only kilojoules per mole. So if you get that correctly, you should be able to get 3 marks in total. All right, D, the experiment is then repeated using sodium carbonate only, powder to replace sodium hydrogen carbonate. Chemical equation number 2 will be this, and the heat of reaction obtained will be negative 36 kilojoules per mole. So now you see if you add in sodium carbonate instead of sodium hydrogen carbonate, you'll get an exothermic reaction instead. So then they ask you to compare the reaction number 1 and 2 based on the change in total energy of the content versus, total energy content of the reactants versus total energy content of the products. So what does that mean? It means that if you remember the energy profile diagram for 2 different reactions. So this is for reaction 1. Reaction 1 is an endothermic reaction, so you will see something like this. Okay, so this is supposed to be the graph shape. And then after that, if you see reaction number 2, reaction 2 is an endothermic reaction. So supposedly, your energy profile diagram looks something like this. Okay, so then you have your reactants and products at different levels, isn't it? And we can see that between the reaction 1 and 2, the total energy content of the products and reactants are different. So for reaction 1, being an endothermic reaction, the total energy content of the reactants is lower than the total energy of the products. Okay, and then for reaction number 2, the total energy content of the reactants is higher than the total energy content of the products. Okay, so it's very simple. Then if you describe that correctly, you should be able to get 2 marks in total already. Right? Diagram 6.1 shows a metal and its composition. So we have copper metal. Copper metal. It's a bronze metal. So it is 90% copper and 5% of element Q. Then they're asking you, right, what is the meaning of alloy? Now, this is not an operational definition. This is a normal general definition. Okay, so the meaning of an alloy is a mixture of 2 or more elements where the main element is metal. So you put here alloy is a mixture of 2 or more elements in which the main element is a metal. All right, and then after that, state the element Q. So Q here is supposed to be tint. All right, 5% of tint, 90% of copper. Then B, diagram 6.2 shows the apparatus set up to investigate the rusting of iron. So we have a jelly solution with a little bit of potassium hexacyanophosphates 3 solution and also a phenolphthalein indicator. So for the test tube A, what you can see here is that the iron nail is coiled with metal P. Test tube B, the iron nail is coiled with metal Q. And C, the iron nail is coiled with metal R. So there are 3 different metals that coil around iron in different situations. So for the observations made according to this question, for test tube A, there is a low intensity of blue color. For B, it is pinkish in color, while C is a high intensity of blue color. So in this case, there are different situations where different substances are being produced in different test tubes. So write oxidation and reduction half equation for C if metal R is copper. So if metal R is actually copper, what we can say is that iron is actually oxidized, because iron cannot protect iron. Copper cannot protect iron from being oxidized. So therefore, iron will rust. If iron were to rust, then of course it'll release out the iron ions lah. Okay, and then after that, for the second one, reduction of half equation. So for the reduction half equation, what is being reduced over here? Because you see, right, technically speaking, what is the one that is being reduced is the formation of hydroxide ion, because it's rusting process. So for rusting process, water and oxygen combines together to release out hydroxide ions. Then you'll get 4 OH minus. And then you have 4 marks. Right? Balanced chemical equation for both sides, half equation, you get 4 marks in total. And then based on diagram 6.2, which test tube shows rusting? Explain your answer. So it is actually A and C lah. The one that has a change in color, a blue color intensity in the presence of hexacyanophosphates 3 will be able to show you this rusting process. So you put here test tube A and C. Because the blue color of the solution proves the existence of Fe2 plus in the solution. Okay, then you say here iron is in contact with a less electropositive metal. Okay, all right, let's move on to the next question. For number 7, diagram sample 1 shows 2 reagent bottles. We have A and B, one which has 0.1 mole per dm cube of concentration, while the other one is 0.001 mole per dm cube of concentration. So state the meaning of strong acid. So strong acid is an acid that will ionize completely in water to produce high concentration of hydrogen ions. So you put here an acid which ionizes completely in water to produce a high concentration of hydrogen ions. Okay, based on 7.1, which reagent bottle gives a lower pH value? Now, lower pH value means more acidic. Okay, and obviously the one that has a higher concentration should be should have a lower pH value. So you can say here bottle A, okay, bottle A, because bottle A has a higher number of mole or higher molarity, okay, in terms of acid. So therefore it must have a lower pH value. So you get 1 mark over there. For B2, state the pH value of HCl in the bottle B. Very simple. pH value is equivalent to negative log concentration of hydrogen ions. All right. So right now our concentration for bottle B is 0.001 mole per decimeter cube. So in this case right now, all you have to do is just to calculate what is negative log 0.001. And the answer here is supposed to be 3. So therefore, the answer here will be 3. You get 1 mark. Okay. Right. Let's go to C. Diagram 7.2 shows the titration method carried out by a student. So this is titration between sulfuric acid with potassium hydroxide solution with a little bit of addition of phenolphthalein indicator. So write a balanced chemical equation for the reaction above. So sulfuric acid is H2SO4 plus KOH. You'll be able to get K2SO4 plus 2H2O. Balance chemical equation plus the correct formula will technically give you 2 marks in total. The experiment is repeated by using ethanoic acid. Which acid will use more volume? Explain your answer. So we will say that if you're going to change your sulfuric acid to ethanoic acid, which is also a weak acid, by the way. So, of course, more volume is needed because inside ethanoic acid, there are lesser amount of hydrogen ions. So in this case here, all you have to do is just say that if ethanoic acid is used, the volume of acid needed will be higher. Okay. So next, what will happen is, okay, now I justify why. So you say that ethanoic acid is a weak acid. That ionizes partially in water to produce lower concentration of hydrogen ions. Okay, so you say here that more acids required because there's an increase in hydrogen ions, but actually it's enough really to get 3 marks over here. So how is the mark distributed? It's actually very simple. If you say that more acid is used, volume needed is higher, you get 1 mark. Mentioning that ethanoic acid is a weaker acid is also 1 mark. And then after that, explain that it has a lower concentration of H plus ions. You will also get another 1 mark already. So total, you get 3 marks already. Okay. So this is just to compare it against sulfuric acid lah. If it can technically justify that it is weaker compared to sulfuric acid, you should be able to get the marks already. So for number 3, during the experiment, what should you do that the volume of acid used while hydrogen is doubled than in diagram 7.2 justify actions? So I think very simple. If you want to technically double, if you want to double the volume of acid used, then you should reduce the concentration. All right. Or let's see. You either reduce the concentration or you can change it to a monoprotic acid. Because right now what happens is that you have a diprotic acid, right? Where H2SO4 dissociates in water to give you a lesser amount of hydrogen ions. Okay, so therefore what happened now is that we are going to, in order for us to use double the volume, but maintain the same concentration. Maybe like, okay, you want to maintain the same concentration but double the volume, then you can actually use a monoprotic acid, such as hydrochloric acid or nitric acid. Otherwise, then you have to reduce the concentration of the H2SO4. So therefore, the first type of answer you can put in will be to reduce the concentration of sulfuric acid by half if you want to. Otherwise, you can also do this. Replace H2SO4 with a monoprotic acid such as hydrochloric acid or nitric acid. Okay, so if you write the first one, you must justify why. Okay, like the first answer we give, you must say that if you reduce the concentration by half, the amount of hydrogen ions also will be half. And then for the second one, if you say you want to replace it with a monoprotic acid, you'll have to show an example, okay, or what kind of monoprotic acid. So you must put that such as HCl or HNO3, then you'll be able to get marks as well. Okay, so for number one here, you have to you must justify extra. You must say that because by reducing the concentration of H2SO4 by half, the concentration of H plus ions will also be half. Or you put a halved. Number 8, diagram 8.1 shows the structural formula of a carbon compound X. And this is a 2-carbon carboxylic acid. So state the meaning of carbon compound. It's very simple. For carbon compound, we usually call it as a compound that contains carbon as the constituent element. So for carbon compound or compound, that contains carbon as their constituent element. So constituent element means it is the main component of the particular element, of a particular compound. Right, state the functional group of compound X. The answer is carboxyl group. So carboxyl group is the one that contains COH. So if you were to put dash COH also can. Okay, so this is 1 mark. Compound X reacts with compound Y to produce methyl ethanoate. What is the chemical formula of compound Y? So since the name of the alcohol comes first, so methyl represents a 1 carbon atom alcohol. So the chemical formula of compound Y should be the formula of wait, this is X or Y? This is X. So Y should be methanol. So for methanol, over here you can put CH3OH. Okay, so this is X, right? This is X. Y should be the corresponding substance. So methyl here means methanol. So that is methanol's chemical formula. Write a balanced chemical equation for our answer in B1. So that's very simple. You can just write CH3OH plus CH3COOH. Then you'll get the compound substance, which is CH3OO C, right? OOC H3C. Actually, no, not I'll teach you an easier way to do this. All right. So normally, right, for the alcohol, we remove the H. For the carboxylic acid, we remove the the OH. So what happens is usually like that, okay? The alcohol structure looks something like this. Okay, this is methanol. And then for the carboxylic acid, usually it is something like this. Okay, this is the for people who don't really know how to picture this whole chemical reaction in their mind lah. Okay, so like I said just now, we're going to remove off the hydrogen from the from the alcohol, and then we're going to remove all the OH from the carboxylic acid. Then after that, what happens is that they'll combine together. So you bring this one close to over here, and it looks something like this. So to write the formula over here for the product, be very simple. So all you have to do is just to write CH3, all right, condense this part over here together, right? CH3 over here, sorry. And then you see, right, this one put together also. So it will be what? It will be OOC, and then after that you have your CH3. So it'll be C2H3. Like that, okay? If not, then another way to do this is very simple. The product being formed over here will be CH3, and then you take the C and put it in front over here, so it'd be COOCH3. Also can, right? So it depends on how you want to draw the structure. So technically speaking, right, this is the branch part. This is where the ester linkage is formed. So this part here is from the carboxylic acid, and this one comes from the alcohol. So it depends on whichever section you want to put it in. But in this case here, I'm just going to write down the one that I have right now. So it'll be CH3COOCH3. Okay, so that's the easiest one you can write. And remember, there is a removal of water. So don't forget the water part as well. Okay, all right, so let's move on to the next part. For C, diagram 8.2 shows a flow chart of a series of changes that occurs between some members of the homologous series. So butene, after undergoing process number 1, it forms compound A. The required condition will be nickel catalyst at 180 degrees Celsius. And then for process number 2, it produces compound B, but in this process, it requires phosphoric acid as a catalyst, and it requires 300 degrees Celsius and 60 atm of temperature. So state the general formula of compound A and B. So if you don't know what has going on over here, this is butene, right? So butene undergoing hydrogenation is process 1. Okay, why? Because you see a nickel there, you will automatically know that it is hydrogenation, okay? And then what you're going to get over here will be butane, okay? And then you can see there phosphoric acid, 300 degrees Celsius, 60 atm. That it will most likely be alcohol already. This is actually hydration process. So therefore, that will be butanol. So then after that, they ask you to write the general formula for the compound of A and B. So A is alkane. So the general formula will be CnH2n plus 2. And then for the alcohol, is B. So it's CnH2n plus 1, OH. So you write this down correctly for both the general formula, should be able to get 2 marks in total. For number 2, describe a chemical test to differentiate between compound A and compound and butene. So whenever we want to differentiate an alkane with alkene, we actually use something called bromine water test. Okay, so you just say bromine water test is used. So you see over here, add a few drops. of bromine water into two separate test tubes containing compound A and butene. After you say that, shake both test tubes. So you see over here that the test tube that contains butene decolorizes, but test tube of compound A remains brown. Okay, now the mechanism of this is very simple. Because when you add bromine water is basically Br2. Okay, so Br2, if you add it to both solution, you can either add it into C4H10 or C4H8. In this case, bromine can only react with C4H8. It's because there's a carbon-carbon double bond between them. Right, so imagine that you have a carbon-carbon double bond here, right? The carbon-carbon double bond can actually open up to accommodate the bromine atoms. Okay, so what you get later on is basically a 4-carbon atom, alkane supposedly, and then there'll be a dibromo in front. So this process is actually known as bromination or addition of halogens or halogenation. But it cannot happen in alkanes because alkanes are saturated molecules. There is actually no double bond, or there's no more electrons, valence electrons for the carbon atoms to react with the bromine to form a compound. So technically speaking, there's no reaction for the first one, but there is a reaction for the C4H8, which is the butene. Okay, so therefore this is 3 marks in total. Let's move on to section B. So for section B over here, diagram 9.1 shows the atomic structure of P, Q, and R. So we got 6, 6, 8, 8, 11, 12. State the meaning of nucleon number and proton number. So I think that'll be very easy. For nucleon number, it is the total number of protons and neutrons. Okay, and then the proton number is equivalent to total number of protons in the atom. Okay, so that's how we define the nucleon number and the proton number. For the nucleon number, right, you can add in a little bit more. You can say that total number of protons and neutrons are in the nucleus of an atom. Okay, that sounds more direct and more specific. So after that, they get 2 marks in total. And then they ask you to write the electron arrangement of atom P and atom Q. So atom P's electron arrangement will be 2 shells, right? And then you can see there's 4 valence electrons, so therefore it'll be 2, 4. And then for Q, it is 2, 6. And then you'll be able to get 2 marks as well after that. And then for C, based on diagram 9.1, write the balanced chemical equation between the element Q and also R. So Q, apparently, you see here, this is supposedly, like if you look at the periodic table, you will notice that this is supposed to be oxygen. And since this is supposed to be oxygen, it must exist as a diatomic molecule, which is O2. But we don't call it O2, we call it as Q2. That's the natural state of element Q. And if we were to react with R, you can see R is actually a group 1 element because it has only 1 valence electron. So in order for it to react with this, you need 4R in total. 4R plus Q2 to get technically 2R2Q. Okay, supposedly, if you see properly, Q is supposed to be oxygen, R is supposed to be sodium. Okay, so you know that sodium oxide, supposedly the chemical equation is 4Na plus O2. Then you'll get 2Na2O, correct? So this is how we can balance the equation. But instead of using Na or O, we're using R and Q. So this one is actually the similar to this one. But like I said before, you're not allowed to change the alphabets of the substances that they give you based on what you know in the periodic table. You have to follow back the same symbol that's given to you, although they're not the exact ones. So we just convert the equation here from the original one to the alphabets that they give you. So this is the answer. This is 4R plus Q2, get 2R2Q. Then you get 2 marks for a balanced chemical equation. C2, calculate the mass of the compound formed if 2.3 grams of R reacted with Q in excess. So right now, we're going to use back the same equation over here. So right now, we have a total of 2.3 grams of R. So number of mole of R will be 2.3 grams divided by, now they actually didn't give you the relative atomic mass of R, but they did show you the nuclear number. So the nuclear number, the nuclear number over here is 11 and 12. So the mass of the atom, the relative atomic mass, depends on the number of protons and neutrons in total. So if you add 11 protons and 12 neutrons, you should be able to get a total of 23 grams per mole as a molar mass. So this will be dividing by 23 grams per mole as the molar mass. So if you were to divide that, 2.3 divided by 23, you'll get 0.1 mole. All right, now if you were to compare in terms of ratio, this is 4 to 2, right? So if you were to simplify, it will be actually 2 to 1 . So we know that the ratio between R to Q, R to Q, it will be 2 to 1. So therefore, the number of mole of R to Q should be 0.1 to 0.05 mole. Okay, this is just to compare in terms of ratio. So now what you have is 0.05 mole of R2Q, which is the compound itself. But we want to get the mass of the compound. So to get the mass of the compound, you have to first add in the molar mass of R2Q lah. So the molar mass of R2Q will be, okay, so you got 2 times 23 plus 16, because this is 8 plus 8, so 16. So then you'll be 46 plus 16. Let me see how much is that. 46 plus 16. 62 in total. So the molar mass is 62 grams per mole for the compound. So therefore, the mass of products being formed, mass of the product being formed will be 0.05 mole multiplied by 62 grams per mole. Your answer will be 3.1 grams. Okay, so this is a sort of like an indirect method lah. Why? Because they didn't give you the information that you can get directly. Usually what they do is that they give you the relative atomic mass or the molar mass of the substance in the question itself. However, in this question, you see they didn't give you anything, so you have to find out what are those values. So you have to trace back and see, like, because they give a neutron number inside here in the picture, so you can actually get the information that you need based on this picture, but you have to look out for it and get it on your own. So after getting it correctly, you should be able to do the calculations. It'll take some time, but you'll definitely get 4 marks worth of, you'll get 4 marks of worth of answers lah. So you can just calculate it, get your answers correctly, should be okay. Okay, for the chemical equation, why can't you write 2R plus Q? Some people actually write something like this, 2R plus Q. Now, I did mention before that Q is supposedly a diatomic gas. If you see properly over here, Q has 8 protons and 8 neutrons. So therefore, if you refer this to a periodic table, you will notice that it is actually oxygen. All right, oxygen has a symbol of 16-8 lah. So if you look at this Q, right, Q has a similar standard representation as well, which is also 16-8. So if this is 16-8, right, it will form a diatomic gas, meaning to say that it must be in a molecule form, because to be stable, to achieve octet electron configuration, 2 of atom Q must come together and share electrons, and they share 2 electrons to achieve octet. So when they form diatomic molecule, in your chemical equation, you must write down the state or the formula of the substance in its natural state. So natural state means that in the natural environment, how does it appear to be? So in this case, since oxygen cannot exist as a single atom, or Q, should I say Q, cannot exist as a single atom, so we must put Q2 instead of Q only. Right, because Q alone is not octet, Q2 only can achieve octet. So you have to use that as an explanation. I mean, I'll explain to you in that way. We don't understand. Is that okay for you to understand? Okay, so you must in any chemical equation at all, you definitely must be able to differentiate which ones are monoatomic, which ones are diatomic. So things like halogens must be diatomic, right? You have F2, Cl2, Br2, I2, and then you can also have things like, for example, O2, N2, H2. Those are gases or liquid or solid, which are all diatomic. And then you have noble gases are monoatomic, which means can be single atom, like helium, neon, argon, krypton, xenon, radon. All those have to be in a single form lah. But then again, of course, the inner gases don't react, so it doesn't matter. All right, let's go to number 9. Diagram 9.2 shows the molecular structure for covalent compound in A and B. For covalent compound A and B over here, you can see, right? A represents something similar to diamond structure. All right, it can be silicon oxide or it can be diamond. It's a macromolecular structure. And then for the right side, it's just 5 different atoms covalently bonded together. And that's a very simple molecule. So we call this as a simple molecular structure. All right, then after that, what you say here is that state what type of covalent compound A and B, and then suggest an example of both compounds. Compare both compounds in terms of structure, chemical bond, melting point, and also boiling point in total. All right. It's going to be very long, but what you can do is you can draw a table to explain the differences between them. So let me just first suggest these 2 compounds. So compound A, we put it as diamond. And compound B, I put here as methane. Because the first thing comes to my mind is methane. Okay. All right. Now, let's just draw a table, perhaps. I'm just going to divide it into half so that it's easier for you all to see the comparison between the answers. All right. So this is for A and this is for B. So I already give suggestions to the name already. Yeah? So you can see over here, this is bracket diamond. And then B bracket methane. So I get 2 marks already for suggestion. Technically 1 mark for each, actually. Okay, 1 mark for each. Huh? So here I got 1 mark, here I got 1 mark. Then now we explain the properties. So we'll say that diamond is a giant covalent structure. And then for this part here, you just put here simple covalent structure. You can also put simple molecules, okay? All right, so you get another 2 marks over here. And then 7 comparison, what they want you to compare is also what? Also based on chemical bonds. So you can say here that all the atoms in diamond are covalently bonded. Okay. And then you see over here, weak intermolecular forces between the molecules. Okay, so this is another 2 marks. So total got 6 marks already, yeah? Right, 2 marks for the example, 2 marks for the first comparison, 2 marks for the second comparison. Right, and I ask you to talk about the melting and boiling point. The third one you see here, high melting and boiling point. And then this one is low melting. Boiling point. Again, you get 2 marks already. And then the last one, you can explain why they have a high melting and boiling point, and the other one is they have a smaller or lower melting and boiling point. So you can say here a lot of heat energy is required to separate the atoms from one another all of the covalent bond must be broken. That's why diamond has a melting point of approximately 4,000 degrees Celsius, because everything is like covalent bonded, so you have to break those covalent bonds. However, for the other side, for the simple molecule and methane, we're not breaking the covalent bonds, we're actually breaking the intermolecular forces like van der Waals forces. Okay, so here you see here the molecules of methane has very weak intermolecular forces that is broken easily with small amount of heat. Then you'll be able to get another 2 marks over here. Right, so generally, very simple. Okay, you can see here, all I did was I just draw a very simple table, and what I do is that I then compare one point with each other. Okay, now I don't have to write everything in a paragraph form, it's because it's very hard for you to write everything there. I mean, if you want to write in point form, you are allowed to, so don't worry lah. All right, but otherwise, I'll say comparison questions like this is easier for you all to just draw a table, draw a very nice table, very, very simple one. All right, and then write the points of comparison side by side. You want to separate each and every row also can, like if you want to, like this, huh? All right, but I don't find the need of it. I don't find the need of it lah to do so. Okay, so all I can do is just like draw a line across over here and then just box it up, then done already lah. Okay, but it's entirely up to you. You want to draw lines in between to separate out the points also can, it doesn't matter. I mean, it looks neater also in a way, right? But like I said, it's up to you lah. It's based on your own preference. If you don't want to, it's okay, man. So all these comparison will give you 10 marks in total, which in my opinion is actually very easy to get if you know how to explain this in detail, right? Comparison wise, because you just write very small and very short answers, and you can get like 10 marks in total already, which is really, really worth it, lah. Okay, now number 10, diagram 10.1 shows coral reefs found in Cebu Island. These coral reefs are formed from salt X. Salt Z. So state the meaning of the salt and the name the insoluble salt. So normally for these corals, they are made up of calcium carbonate. Okay, and it is actually an insoluble salt. Okay, so what I can write over here is calcium carbonate. And if you were to react with the state the meaning of salt. So salt is a compound formed when a hydrogen ion from an acid is replaced with a metal ion. So the definition of salt, a compound, okay, formed when the hydrogen ion, of an acid is replaced with a metal ion or ammonium ion. Okay, so that is the definition of salt. And name the insoluble salt over here. The insoluble salt here will be calcium carbonate. So Z is C is, okay, you must name it. because they say name, so you must name it. You cannot put the chemical formula. So Z is calcium carbonate or limestone. All right, and then diagram 10.2 shows the apparatus set up for the reaction of hydrochloric acid with solid salt Z. So Z is heated up. Z is reacted with hydrochloric acid, and then lime water test is conducted. So they ask you to solid Z salt contain calcium element, which is salt Z, and the gas released during the reaction in diagram 10.2. So okay, salt Z is salt Z is calcium carbonate again. So put here salt Z is calcium carbonate. And the gas release is carbon dioxide. Okay, so I got 2 marks over there. Very simple. All right, next question number 10. Table 10 shows the result of experiment by studying the factor that affect the rate of reaction. So we have zinc plus sulfuric acid. Second one is, again, zinc plus sulfuric acid with copper 2 sulfate. And the last one will be excess zinc powder plus sulfuric acid also, but done in a different temperature. So basically, experiment 1 and 2, this is 1 and 2, 1, 2, and 3. Experiment 1 and 2, they used different, they use catalyst for 1 and 1 is without. And then for the experiment number 3, they use a different temperature. Right? Now, the time taken is 20, 12, and 10 seconds to create 30 cm3 of gas. So in this case here, write the chemical equation for the reaction between zinc and sulfuric acid. So that's very easy. The chemical equation is Zn plus H2SO4. You get ZnSO4 plus H2. And after that, what we have here is the next one will be calculating the average rate of reaction for experiment 1 and 2. So chemical equation wise will be 2 marks already. Now the next one calculation is just another 2 marks lah. So for experiment 1, rate of reaction will be 30 cm3 divide by 20 seconds. So that will be 1.5, huh? So that will be 1.5 cm3 per second. That's the answer. And then for experiment 2, all right, rate is equivalent to 30 cm3, same volume, divided by 12 seconds. So then this will be 2.5 cm3 per second. So if you get all this correctly, you should get 4 marks in total. 2 marks from the rate calculation and 2 marks from the balanced chemical equation. All right, now I ask you to sketch a graph of volume against time for both experiment in the same axis. So it's very simple. The sketching part is just no need to plot lah. You just draw the y and x axis. So the top one will be volume of gas. In cm3, and then this will be time in seconds. All right. Then remember your maximum volume of gas is 30, but I don't usually write it down first. What I do is I sketch the graph first lah. So this is one of it, and then one more higher than that. That should be correct already. Something like that lah. And then only you put the T over here. Easier for you. Okay. All right, so they'll end up at the same point because the amount of gas released is still the same. The only thing is that one will be steeper than the other. So of course, you must also label your graph lah. Experiment 1, experiment 2. So usually I'll write here experiment 2, and then over here will be experiment 1. Then you'll be able to get 2 marks. You must label your graph. If you don't label your graph, it's wrong. They don't give you marks for it. So it's very simple. All right, let's go to question number 10. Based on table 10, compare the rate of reaction between experiment 1 and 2 and experiment 1 and 3. So we've got 2 separate experiments to compare. Okay. The first one, experiment 1 and 2, is actually about catalysts. Right, to compare the presence of catalysts. While the other one we're going to compare in terms of temperature. Because as you can see the table above, we actually notice that the presence of the copper 2 sulfate, which can actually add an added effect where the copper 2 sulfate can act as a catalyst to actually increase the rate of reaction. Right? While the first experiment has no copper 2 sulfate solution, so it will be slightly slower compared to the one with copper 2 sulfate. And then between experiment 2 and 3, they notice that there is actually a difference in temperature. So one is 30 degrees Celsius, but the other one is actually 40 degrees Celsius. So therefore, we know that the second factor or the second part is actually comparing between temperature. So in this case, now since we already know what to compare already, let's take a look in what the question actually wants. So in this case, they say based on table 10, compare the rate of reaction. And then it says here, in each case, state the factor that affect the rate of reaction, and then explain the difference. Right, explain the difference in the rate of reaction based on the reference to collision theory. So it's very simple. If you remember what the collision theory is, then it shouldn't be a problem. Now we're gonna compare it in different section where the catalyst itself we're gonna describe around 5 marks worth of answers. And then for this part over here, we'll describe another extra 5 marks so that later on we'll get 10 marks in total. Okay. So I've already prepared the answer for you. This is my suggested answer. So for experiment number 1 and 2, we're going to explain in terms of the presence of a catalyst. So the factor that we compare right now is actually catalyst. So if you were to mention the word catalyst, you should actually get 1 mark already. So you see over here, experiment 2 has a higher rate of reaction compared to experiment 1. So this is the comparison itself. We say that experiment 2 has a higher rate of reaction compared to experiment 1. Okay. And then we also said that, copper 2 sulfate here acts as a catalyst, which already indicate that we have a catalyst as a factor that increases the rate of reaction. And then we have to explain how the catalyst actually works when it comes to the collision theory. So we say over here that it actually provides an alternative pathway with a lower activation energy for the reaction to proceed forward. And then we also mentioned that there is actually an increase in a number of successful collision. Now, the very dangerous part over here is that sometimes students don't know that actually, right, catalysts do not increase the number of collision. They only increase the number of successful collisions or effective collisions, as we call it. So you must be very careful not to mention the word number of collisions, because they don't actually increase the number of collisions. What they do is actually just to lower down the activation energy so that the reaction can proceed forward, more successful collision can happen. Okay, so you cannot actually include the number of collisions alone. That will be wrong in terms of explanation. All right, and then therefore the rate of reaction will increase. So if we get all those points correctly, you should be able to get 5 marks in total for the comparison between experiment 1 and 2. For experiment 2 and 3, you can see over here, right, it has a higher rate of reaction compared to experiment 2. So again, I'm actually comparing, all right, in terms of the rate of reaction for both experiments. Okay, I also mentioned that the acid is used, the acid solution used has a higher temperature compared to the experiment 2, but I think I missed out one word over here. So you're supposed to add here for the second point here, my mistake. You have to actually include here temperature. Okay, so temperature. So what I can say here is that the acid solution used is higher it has a higher temperature for experiment 3 compared to experiment 2. So I missed out that. So maybe you can just cancel this off. Okay, so maybe I just rewrite it over here for you in case you're confused. So just put here temperature of acid used in experiment 1 in experiment 3 has a higher rate of reaction. Sorry, has a higher temperature than experiment 2. There you go. Okay. So after that, you can continue on. So when you say when temperature increases, you already indicate that you are actually using temperature as a factor to increase the rate of reaction. So once you're done with that, you can actually go on to the next point and explain how the temperature can actually affect the rate of reaction through collision theory. So you say here, when temperature increases, the kinetic energy of the particles will increase, causing their movement speed to also increase. And because of that, when they move faster, means there's a higher number of collisions. For this case here, you can say number of collision because the particles are colliding, and because if you increase temperature, the movement speed of the particles increases. So of course they'll collide more often, right? So they do actually increase the number of collision in a shorter period of time. And the last one will be to increase the number of successful collision as well. So when you have more collisions between the particles, you actually have a higher number of successful collision. So if you describe everything correctly, you should be able to get another 5 marks for that. So 5 marks for the first 2 experiment comparison, and then another 5 marks for the next one. You should be able to get 10 marks in total. All right, and I think it's quite easy as long as you remember your collision theory. Now let's move on to the next question, which is section C, the last question for number 11. So diagram 11.1 shows the apparatus set up to study a redox reaction. So what we have over here is zinc dipped into a porous pot containing zinc sulfate solution. And the whole setup is actually dipped into another beaker, which is filled with copper 2 sulfate. And on the right side, you can see copper electrode is being immersed into the copper 2 sulfate solution. Okay, now let me give you the standard electrode potential for the zinc and copper. What is the meaning of redox reaction? So it's very simple. Redox reaction is actually a reaction where oxidation and reduction occurs simultaneously. Okay, so that's the answer you must put inside. So therefore, you can put here redox reaction is a reaction where oxidation and reduction reactions occur simultaneously. So if you answer that correctly, you should be able to get 1 mark for the explanation, the definition. So next one will be B. Identify the negative terminal and positive terminal of the cell. So the more negative the value of the standard electrode potential, the more likely you'll be the negative terminal. And the more positive the value, the more likely you'll be a positive terminal. So in this case here, you see, right, that the standard electrode potential value of zinc is actually more negative, while for copper is actually more positive. So I'll say that zinc becomes the negative terminal, while copper becomes the positive terminal. So you can put over here negative terminal is supposed to be zinc, and the positive terminal is supposed to be copper. So if you write all correctly, you should be able to get 2 marks in total. And then for next one, write the overall ionic equation. Now, if you guys know how to write ionic equations properly, I mean, if you guys are pro already, then you will have it in the back of your head. So it should look something like this. So if you don't know how to get all the way to here, what you can do is you can write the two half equations that you see. Okay, so the first half equation will be zinc dissolving in the electrolyte to form zinc ions, and 2 electrons are released. Okay, and then after that, it is accepted by the copper ions to form copper atoms. Okay, so what happens here is that you have the first one, which is the oxidation reaction, and the second one will be the reduction reaction. Then to write an overall ionic equation, you have to combine the first and the second one together. So what you can do is you can just cut off the electrons. In this case, whatever that's before the arrow, place them together. That's a shortcut method. And then whatever that's after the arrow, you place them together. Okay, and then you'll be able to get the ionic equation. So you can see, right, this one over here is exactly the same as this one over here. So for people who are professional, they feel like, oh, I already have this in the back of my head, so you can just straight away write the whole ionic equation without writing the half equation. Okay, as long as it's balanced and it's correct, you should be able to get 2 marks in total. However, if you don't know how to write the ionic equation straight away, what I can recommend to you to do is actually to write the half equation first and then combine the 2 half equations together. Make sure your electrons are equal on both sides so that you can actually cancel them out. That's it. So once you're done with that, then it's already done, finished. All right, and then I ask you to write the cell notation for the chemical cell. Referring to your textbook, you'll be able to remember that you will have to place the electrode first on the left side, followed by the ions in the electrolyte. Then you have a salt bridge, and then the next one will be the other ion, and then the other electrode. Okay, so how I'm going to write this is very simple. All you have to do is just to write zinc solid separated with a line, and then you write there Zn2 plus Aq, and then you'll be the salt bridge in the middle. And then same thing also, you can see here there is supposed to be a copper 2 sulfate solution, so copper 2 plus, all right, bracket Aq, and then separated by another line. Then after you write there Cu solid. So as long as you write this correctly, you should be able to get 2 marks in total. And I ask you to calculate the voltage of the cell. So the voltage of the cell is technically the standard electrode potential value for the positive terminal. So what I'm going to do is that I'm just going to put a plus sign over here, minus standard electrode potential value of the negative terminal. So using the whatever we have over here, it will technically be 0.76 and 0.34. So we have is 0.34 minus negative 0.76. So that will be equivalent to 0.34 plus 0.76. Your answer is supposed to be positive 1.1 volts. So you get the final answer from the calculation. You'll be able to get correct in this case. Okay, and then after that, diagram 11.2 shows the apparatus set up for cell A and cell B. So what we have over here is we have 2 separate cells, if we see properly, right? This one over here is the chemical cell, while this one over here is supposed to be technically supposed to be an electrolytic cell. So what happens here is that later on you'll notice that there's supposed to be a chemical reaction, but we're going to discuss that later. So compare cell A and cell B in terms of product form, observation, and half equation at the A0. So we'll start with cell A. So cell A is over here. So cell A is referring to the chemical cell, where you can see, right, zinc is deep inside the porous pot, can contain zinc sulfate, and then we have copper, which is deep inside copper 2 sulfate solution. So I would say that you can just explain what cell it is. So for cell A, right, they want you, for both cell actually, for cell A and cell B, they want you to explain in terms of product form at the observation. Sorry, product form, observation, and half equation. Supposed to put a comma here. State what product it is. So what product is formed in the zinc part in cell A will be very simple, because zinc actually dissolves and zinc ions are released. So the product over here should be zinc ions, okay? And after that, they ask you to write an observation. You can say that the zinc or the negative terminal dissolves. So very simple. The second part over here, just right there. zinc terminal or electrode dissolves, right? So right now, I would say product over here, let's put here product for cell A will be zinc ions, which is Zn2 plus. And after that, your half equation is here. And then what happens at the observation part will be this one. Okay, so then you have 3 marks in total already if you write all this correctly. And on the right side, what happens is that the product being formed will be technically copper, okay, copper, because you can see here they're using both as copper electrode, but the right side for cell B is actually an electrolytic cell. So I would say that the product in cell B will be copper atoms or solid copper, because later on you see I'll show you the half equation. So for the half equation part, right, you can just write here copper ions will accept the electron and they'll form copper atoms. Okay, so you got 2 marks really. One is one you restart the if you restart the product, and the other one you write down a half equation, you should be able to get 2 marks in total already. And then you're supposed to state your observation, right? So there are 2 observations in this case. One is that the copper, actually no, there's only one, sorry. Copper electrode becomes thicker. Okay, copper electrode. Okay, there's 2 copper electrode. There's one over here and there's one over here. So it depends on which one you describe. So what happens is that supposedly this side over here, there'll be more copper being formed on the surface. So you can say that copper electrode on the right side of cell B becomes thicker. If you're talking about this one over here on the left side, then it becomes thinner. Okay, so it's up to you whichever you want to choose that. As long as you can actually explain and understand what's going on over here. So I would say that the best one will be, of course, the right side becomes thicker because more and more copper atoms are being formed. That's it. So you write down all 3 points inside there, you also get 3 points. So 3 plus 3 will give you 6 marks in total. Okay, last question. Farida's house is located at the seaside. Okay, so she has a problem when the steel doorknob always need to be replaced because it is always rusting. It makes a lot of sense because if you're near to the ocean side, what will happen is that they will have this water from the sea, which is salty, right? So you'll cause an accelerated form of corrosion, and that the doorknob will always be rusty. Okay, so as Farida's friend suggests a way to solve the problem by using electrolysis concept. Now, if they don't actually explain about it, if they don't mention electrolysis concept, it's actually very simple. You just have to put like grease on top, put oil on top, paint it over, no problem. But in this case now, you have to use electrolysis concept. So most likely this is actually referring to electrolysis or electroplating. All right, electroplating is where you take another metal, you try to overlay or you try to cover up the existing metal with another metal. All right, so in this case, it can be any metal that you want. So for example, here is a suggested, what's it called? A suggested experiment that you can do to actually electroplate the particular doorknob, because they ask you to suggest a way, right? But they didn't say it directly, but this is actually an experimental based question. It's just that you don't have to list down the tabulation of data, the hypothesis and things like that. You just have to write the method, that's it. Okay, so got 6 marks in total over there. So we have to at least have 6 points. So these are technically my 6 points worth of answers. I have to wait, I have to move this around. Okay, so I already wrote this for you. Okay. So the first part, I actually mentioned that you have to clean the copper electrode and the steel doorknob with sandpaper. This is actually to remove the impurities on the surface of copper as well as the doorknob to make sure that the electrolysis goes well. If not, then in the presence of some impurities, the electrical conductivity of the material will drop. Then electroplating will not be so smooth, I would say. Okay. The rest of it is a very standard procedure. You measure the electrolyte used, pour into a beaker, and then you use the copper as the anode and the steel doorknob as the cathode, and then you connect them to wires, and then attach both into the power supply. And then after that, what you do is that you put the two electrodes, immerse them into the solution, and then you turn on the power supply and make sure that the person actually rotate it, and also do it for around an hour. So that 6 procedure, that is enough for you to actually get 6 marks in total already. If you want to add in any additional steps or you want to put in more detailed form, by all means you can, okay? There's no right or wrong in that sense. It's just that for me, if you can write a minimum of 6 points, which is relevant, then you should get 6 marks already. If you want to play it safe, maybe I'll save 7 or 8 steps so that you can hit the keywords now. All right, once the keyword is there already or the key phrases is there, the examiner will most likely give you the marks that you need. Okay, so that's all pretty much about this paper for Johor 2021. I hope you guys have learned something or at least managed to do some revision with these materials. So that's all for me today. I hope to see you guys in the next video.